Hello, my name is Steve Serafian. I'm a sales support engineer at Sony, and the topic here is the daunting issue of archive and Sony's solution. Before we get started with the presentation, I'd like to make a few observations and comments. Today, file-based workflows are a way of life. There never seems to be enough storage for the files we create or manage. There's a growing population of memory card-based camcorders on the production side and video servers and shared storage on the post-production side. This transition away from videotape to file-based workflows have created the need for a reliable long-term digital archive. Typically, as I've observed at several facilities, there are many hard disk drives stored under desks or in cabinets as the only form of long-term storage. In post-production and editing, freeing up space on shared storage server is an ongoing challenge. During a recent visit to a major broadcaster, one of the engineers commented to me that the videotape library is gone now, but nothing has replaced it. Unfortunately, it is not uncommon to hear about data loss due to flooding caused by a natural disaster or by a water main break in an aging plumbing and infrastructure. So let's get started. Some of our users back up their memory cards to XDCAM disks as an archive. Within the limits of the highest 128 GB disk, this is a good approach. Beyond this capacity, we have Optical Disc Archive media. It provides a larger capacity up to 1.5 terabyte and at a lower cost per gigabyte than XDCAM disks. Through either a simple drag and drop process or with a Sony or a third-party backup application, archiving with a PC, Mac, or Linux is easy. Note that the Optical Disc Archive product is not only for archiving your files from Sony camcorders, but from any manufacturer's camcorder. It is file format agnostic. Your Alexa, Canon, and Red users, to name but a few, can all use Optical Disc Archive. So how do you protect data for the long term? Hard drives, both standalone and JBOD, require data protection and periodic data migration due to its limited media life and susceptibility to head crashes, vibration, and mechanical failure. Even RAID arrays are susceptible to data loss with multiple drive failures. LTO tape, although initially economical, requires data migration every 2 generations to maintain compatibility with next-generation LTO drives. Also, the actual life of tape media may be reduced if not stored in a controlled environment. Sony's solution to protect digital data for the long term is Optical Disc Archive. Optical Disc Archive is based on Blu-ray technology, but inheriting some of the key attributes from Sony's XDCAM Professional Disc media, which has enjoyed widespread success by the broadcast and professional video production community since its introduction in 2004. The optical disc cartridge has a 50-year life. Its generational backwards compatibility trend is expected to continue with each new optical disc archive drive. This is the same concept that we've taken with each generation of professional video recorder and their support for multi-format playback, supporting Betacam, digital Betacam, and HDCAM tapes. Let's not forget that, today's Blu-ray players can still read CDs from 1982. The media is environmentally resilient, is non-contact in use, and has the benefit of random access. Furthermore, there's a growing line of Sony and third-party solutions. Optical Disc Archive is ideal for external and near-line storage when data permanence is crucial. It is well suited for audiovisual and graphics file preservation. Optical Disc Archive is an open format architecture that incorporates the UDF file system, that's Universal Disk Format, and other vendor-neutral standards. Optical Disc Archive is file format agnostic and easy to set up since a standard USB 3.0 interface allows connection to major operating systems such as Apple, Windows, and Linux. Being a portable cartridge media, it is well suited for data exchange and is designed to integrate with nearline robotic libraries and can serve the needs for disaster recovery and shelf storage. The ODS D55U and ODS D77U drives are compact, only 5 3/4 inches wide, 3 1/4 inches tall, and 15 3/4 inches deep. The media is a little over 5 by 5 inches and about 1 inch high, with label areas on the top and the side. A Write Protect tab is provided on the left side. The ODA software utility provides tools for file system rollback, read-only drive operation, and cartridge formatting and cloning. Next, file access performance. So let's take a look at the file access mechanism compared to LTO tape. The Optical Disc Archive cartridge is made up of a set of 12 discs. The drive allows random access to any of 12 discs in addition to random access within a disc. The time to change a disc and mount to the OS is about 27 seconds. Data is written to a single disc in sequence until it is full. Then the next disc is extracted and mounted, and the process repeats. LTO, on the other hand, relies on linear access. The file system is at the beginning of the tape, and it's used to fast forward to the actual location of the file. The maximum fast forward read time for an LTO tape is about 100 seconds. So next, we'll take a look at the file access time comparison. If we look at 3 stages of this process, mounting, access to any file, and then ejecting the cartridge, the Optical Disc Archive drive compares favorably. As you can see, the mount time is nearly equal compared to LTO. The file access time is dependent on the file location for LTO and can be a max of 100 seconds, but it's a maximum of 27 seconds for the Optical Disc Archive drive, with the help of its random access nature. The eject time is also faster for the Optical Disc Archive cartridge, since only one disc needs to be stored back into the cartridge. The range of time for LTO makes this dependent on the location of the file on the tape and the rewind time. All right. ODA's top read spec is impressive at 1.1 gigabits per second. A unique feature with ODA is its ability to browse and scrub a file within a particular disk and play audio and video clips with its read specification. There is no need to retrieve and restore the file before playing. Because of LTO's linear nature, playback and browsing a clip is difficult, if at all possible. Our tests have shown that Optical Disc Archive is faster than an LTO5 drive when reading a file 31 gigabytes or smaller. It can be said that all optical disc technologies are not created equal. These technologies include organic dye-based, used in CDR and DVD-R, magneto-optical technology, and phase change, used in CDs and rewritable DVDs. The recording materials for Optical Disc Archive and XDCAM Professional Disc and Sony Blu-ray do not use organic dye materials, but instead use inorganic materials. What is the difference between a write-once disc and a rewritable disc? Well, for a write-once disc, we are utilizing recording material that is irreversible, thus making the disc write once. In the case of rewritable disc, the material's phase change can be reversed by the laser and reformatting. As you can imagine, the use of inorganic material contributes to the reliability and robustness of Optical Disc Archive as a long-term archiving media. By its nature, phase change technology is very stable and is used in ODA. The change in state from crystal to amorphous, from reflective to non-reflective, by an instant heating and cooling of the disk surface is why the data remains unchanged over time. Non-contact reading allows for more than 1,000,000 read cycles and a spec of 1,000 write cycles for rewritable media. The physical change is at the substrate level of the disc. The estimated life for optical disc archive media using an industry-standard accelerated temperature and humidity aging test is presented in this slide. In the test, discs were stored in an environmental test chamber where the temperature was kept at a constant 60, 70, and 80 degrees Celsius. That's between 140 degrees Fahrenheit and 176 degrees Fahrenheit at 85% relative humidity. Degradation in error rate versus the storage time was measured for each aging temperature and humidity condition. We estimated the average media life end to be the point at which the error rate increased to the limit of the error correction capability for each temperature. This slide shows the result of the well-known Arrhenius plot, where the horizontal axis is a reciprocal of the absolute temperature for aging, and the vertical line is the end of life time in hours for each condition. Extrapolation to room temperature indicates that the average media life is over 50 years. And you might note that this occurs at 104 degrees Fahrenheit on the chart. So at standard room temperature, the life is much longer. Please keep in mind, if the above ISO standard acceleration test was performed with LTO tape, the tape life under this condition of 40 degrees C and 85% relative humidity is less than 5 days. So in addition, compared to data tape, optical disc archive media has an advantage in disaster tolerance situations, for example, water, dust, and heat conditions. Corrosion resistance testing was performed at 35 degrees C and 85% relative humidity in a corrosive gas environment for 295 hours. UV irradiation testing and seawater soak test for 5 weeks was performed. In these tests, the error rate change after testing was negligible. So taking a look at the cartridge, the compact cartridge is a precision-designed cartridge containing 12 discs and a minimum of internal parts. It's rated for a drop shock resistance of 75 centimeters, about 29.5 inches, and a load application resistance of 100 kilograms, about 220 pounds. The cartridge memory is an RFID device and is used to store disk control information such as the disk capacity, the media serial number, and the location of the file system. The cartridge ID can be linked to the cartridge database to fully identify the contents of the media. In addition, the cartridge library case design provides further shock resistance. The cartridge barcode can be used and read through the semi-transparent case. So the lineup includes both write-once and rewritable cartridges for 300, 600 gigabyte capacities, along with a rewritable 1.2 terabyte cartridge and a write-once 1.5 terabyte cartridge. The storage capacity range per cartridge is from 8.5 hours for 300 gigabyte media to 48 hours for 1.5 terabyte media, both assuming 50 megabit 422 HD video. Sony's archive system lineup extends from a standalone drive to a full enterprise-level petabyte library system. So the ODS D55U drive is Sony's single-user solution and is a starter system ideal for the camera owner-operator or a small studio. It's a USB 3.0 drive that plugs directly into compatible Macintosh, Windows, and Linux computers. The ODS D55U and D77U can be used as a standalone archive with simple drag and drop functionality directly from your workstation. For those that wish to manage portable media, Sony provides a file and media management application called Content Manager bundled with each drive. Content Manager offers several media management features normally found in mid to large content management systems. It can create basic metadata automatically using a watch folder, has a cache function to allow release of portable media or memory cards after the file is copied locally. It also creates a low-res proxy for clip search and browse of any cartridge in its database. A Content Manager license is included with each drive. This software is available to download from the Sony Creative Software website. The main feature of the ODS drives are it's a low-cost entry-level archive solution. It uses the Open UDF file system for Mac, PC, or Linux. The drive is mounted to the OS file system like any drive on the computer. So it's an easy connection via USB 3 with drag and drop functionality. It has fast random file access, and each cartridge is mounted as a single volume. The benefits of the ODS drives are easy setup and operation, just like an external USB drive. Each cartridge is mounted as a single unified volume up to 1.5 terabytes. High durability, frequent data migration is not needed, and there's a 50-year media life, and you can start a shelf archive and content management at a very low cost. You can easily share or exchange data by exporting the cartridge database. So this is your entry-level starting point for a simple, long-lasting, disaster-tolerant, shelf-based archive. All right, on to Content Manager. This is a content and media management application for Optical Disc Archive system users. It has an intuitive GUI with browse, search, and archive functions. You can back up and archive video and audio files onto cartridges. It manages archive files efficiently using metadata, extracted and saved in its database when files are archived. It can also manage shelf cartridges or offline cartridges in addition to cartridges in a drive or online cartridges. Content Manager displays a list of archive files, thumbnail images, and proxy video for previewing archive files. The software searches files using metadata. It can also search audio using speech recognition on the PC platform only, and for people using face recognition on both the PC and Mac operating systems. Content Manager also retrieves archive files on cartridges to a computer or shared folder on the network. It is a web browser-based interface for clip browsing and database searching. So based on user feedback, features recently added in December 2013 to Content Manager version 2 include expanded file format support, both standard def IMX, ProRes QuickTime on the Mac platform, Avid DNX HD, and image file format support will be in a release in mid-2014. Currently we have copy verification with MD5 checksum. We have customizable metadata creation and display. We support multi-user login to Content Manager for browsing, and support for a self-describing cartridge via database export to the cartridge. So the basic workflow with Content Manager will take place at any of 3 stages of the production and post-production process. So after acquisition, again with either a Sony or non-Sony camcorder, media from either the memory card or a hard drive is backed up to the Optical Disc Archive drive. Content Manager or other file copy utilities can be used. In addition, a copy of the media may be made for editing. When editing is completed, the edited media and project files are backed up to the Optical Disc Archive media. In this way, the edited project can be easily restored if a new edited version is required. And finally, an archive of the original media and project can be provided to the client. In this way, shared storage for the edit rooms can be purged, freeing up storage space for other projects. On the hardware side, the ODS D55U bundle lists for $69.90 and includes a 300 gigabyte rewritable cartridge, AC adapter, USB 3.0 cable, operations manual, and content manager license key. PC, Mac, and Linux driver software and content manager applications are available for download from the Sony Creative Software website. Sony recommends running Content Manager on a dedicated computer for best practice. Because Content Manager is a web browser application, a web server is installed on the host computer, an Apache web server using localhost 8080. Squarebox CatDV Pegasus, the archive module, is compatible with the ODS drive, and Imagine Products Shotput Pro is expected to be supported as it is in the certification process currently. Next, our newest addition. The ODS D77U drive is now available and is the newest member to the ODA family. It has all of the features of the ODS D55U, but at a greater than 2 times read and write transfer speeds of the ODS D55U. This started shipping in December of 2013. So the general specs for both drives are shown here. Most notable are the transfer speeds of the D55U and D77U. So as a function of media type, the D55U has a top read speed of 330 megabits per second, while the D77U has a top read speed of 1,170 megabits per second. For write performance, the best write speed on the ODS D77U is 730 megabits per second on 600 gigabyte write once media. In practical terms, this means that you can write a full 32 gigabyte S/S card in about 5 minutes. And so the read and write speeds vary with media capacity and type. So the ODS D77U is bundled with the same accessories as the D55U. So looking to the future, the roadmap for ODA calls for a doubling of the read and write speeds in Generation 2, planned for release at the end of 2015. In addition, ODA media capacity will double with the announcement late last year about Sony and Panasonic's joint development of a 300 gigabyte optical disc. The current 1.5 terabyte ODA cartridge utilizes 12 128 gigabyte quad layer discs. This new cartridge under development will use a 300 gigabyte media in a 12 disc cartridge for a total of 3 terabytes. So taking a look at Sony's archival systems lineup, we start with the entry-level ODS D55U, D77U, and Content Manager bundle, just as we reviewed. Then we move on as your library and archive needs grow. We have a 10 cartridge library called the ODS L10. It consists of up to 2 ODS drives, storage for 10 cartridges, robotics, and a bundled file manager application. A dedicated server running on the PCOS is also required for this configuration. When combined with Sony's file manager software, the library is ideal for network attached storage. It provides up to 15 terabytes, roughly 500 hours of 422 high definition in a form factor that sits on a desktop or mounts in a standard 19-inch rack. The next step up is our XDisc Archive system. A strategic part of Sony's media backbone production systems, it is the all-in-one content management and shelf-based archive management system with online streaming proxy for up to 85,000 hours of content. It is our mid-range solution that supports the ODS D55U and D77U drives and the ODS L10. The ODS L10 will also be supported by a new plugin expected to be released in the first quarter of 2014. Coming later in 2014 is the ODS L30, a 30 cartridge library. The PC server is bundled with this configuration and will be supported with Sony and third-party archive management and HSM applications such as Front Porch Digital, Diva, Zendata, and SGL FlashNet. So there you have it. That is the Sony archive story. For further information, please visit our professional website, www.sony.com/professional. Our professional forum is also a good resource to chat among your peers using Sony products, and that's at community.sony.com. Or please contact me directly with any questions. Thanks for listening and watching, and have a good day.